Hey folks, welcome back. In this lesson, we're going to talk about provision throughput for read and write operations. Now, the first three lessons in this section, including this lesson, really cover the fundamentals of DynamoDB. And it's really good to have an understanding of how provision throughput works and how to perform those calculations. Now, I should mention that AWS has recently come out with AWS autoscaling. You can autoscale other things besides EC2 instances, and one of the things you can autoscale is your DynamoDB. So if you enable DynamoDB autoscaling for a table, then its throughput capacity will be dynamically adjusted in response to actual usage, and no manual intervention is required. Now, this is another situation where the AWS DevOps Pro certification exam lags features and services that are actually available. So I wouldn't expect to see AWS autoscaling on the exam at this time, but it's still good to have an understanding of the fundamentals of provision throughput. So let's go ahead and walk through this. So in the DevOps doctrine, let's click provision throughput. Now, this lesson is going to be mostly theory, and we've actually seen provision throughput when working with some of our tables, but we'll touch on it in the management console as well. So let's go into DynamoDB, and note, the dashboard is showing our provision read and our provision write capacity. Now let's go into tables, and let's drill down into our product catalog table, and we see our provision capacity. And we can click on the capacity tab, and note if we wanted to adjust our provision capacity, this is where we would do it. So working with it in the management console is pretty straightforward. Calculating what you need is a little bit more complicated, and when the certification exam catches up with the functionality available, such as autoscaling for DynamoDB, this won't be as crucial. But for now, let's just focus on provision throughput. So for provision capacity, 1 unit of read capacity is equal to 1 strongly consistent read per second, or 2 eventually consistent reads per second for items as large as 4 KB. Now, there's a difference for units of write capacity. It is 1 write per second for items up to 1 KB. So some of the key concepts we need to talk about are calculating required throughput, understanding how secondary indexes affect throughput, and you'll see there's a difference between local secondary indexes and global secondary indexes, and what happens if your app's read-writes exceed throughput. Now, I'll say this one last time. The autoscaling for DynamoDB is a game changer for all of this. But even so, you would have to set your mins and maxes, and it's still good to have that foundational understanding of provision throughput. So looking at our diagram, think of available throughput as a spigot, and our water, otherwise known as data, is flowing to and from our tables. Now in the top view, we have 1 spigot, and we have a lot of water here. That's going to cause a bottleneck. So what do? Well, we essentially need more pipe. We increase our available throughput. All right, so how do we calculate this? Well, let's talk about calculating read capacity first. Now, a key point is that we're going to round up to the nearest 4 KB multiplier. So as we'll see, if our number is 3, we round up to 4. If our number would be 6 or 7, we'll round up to 8. So let's go with 3. And items that are 3 KB in size can still only do 1 strongly consistent or 2 eventually consistent reads per second. And don't worry, we'll see a calculation here in a second. But basically, we need to round this up to 4. All right, now let's go to our key concepts, and we'll have a calculation. So let's talk about a read capacity example first. So our items are 3 KB in size, and we want to read 80 strongly consistent read items from a table per second. We have our 80 items, and we need to multiply that by this 3KB, except we need to round that up to 4, so this number is actually 4. We then divide that by the 4KB for DynamoDB strongly consistent reads. So what we get is 80, and this division here turns out to be 1. 80 times 1, of course, that's 80. So that is our provision throughput required. Now, for eventual consistency, remember, that's not as demanding on our throughput needs. 80 multiplied by 1, but we can divide this by 2. Strongly consistent is twice as taxing as eventual consistency. So with eventual consistency, it's 40 required read capacity units. Okay, now what about write capacity? With write capacity, we're going to round up to the nearest 1 KB multiplier, and our formula becomes the item size, which we have to round up to the nearest 1 KB, multiplied by the number of items. Okay, so let's do an example. Let's say we have an item of size 1.5 kilobytes, and we want to write 10 items per second. So we have 10 multiplied by 1.5 KB, but remember, we have to round that up. So we round that up to 2, and that's divided by 1 KB. Well, if we're dividing by 1, we can basically eliminate this. So it's 10 multiplied by 2, 20 for provision write throughput. Now, what about secondary indexes? All right, let's talk about read throughput for secondary indexes. So our read throughput uses the same read-write capacity from the parent table. So if you read only index keys and projected attributes, the calculations are the same. Now, the only difference is you calculate based on the size of the index entries, not the table item size, but then you still round up to the nearest 4 KB. So just to explain that further, if your table has an item with 6 attributes, but your index only displays 4 of those attributes, the number you're calculating with is 4, not 6. And that's really the point of secondary indexes. There's no need to, it allows you to work with smaller data sets. Now, what about write throughput for secondary indexes? So when you add, update, or delete an item in a table, the local secondary index also consumes write capacity units to perform the action on the local index. So with both read and write throughput for secondary indexes, the really key point is just to understand that your calculation is going to be on that smaller subset, the data that is encapsulated by your index. All right, now what about global secondary indexes? And there is a big difference. Global indexes have their own throughput capacity, and it is completely separate from that of the table's capacity, whereas the local secondary index shares that table's capacity. Now, the global indexes support eventually consistent reads, which means that a single global secondary index query can get up to 8 KB read capacity. So what happens if we exceed throughput? I'm going to go old school and new school here. So as you can see in the management console, you may not have seen this yet, but AWS now supports auto-scaling for DynamoDB. So we can set our minimum provision capacity and our maximum provision capacity, and also our target utilization. So this is telling DynamoDB, hey, if our utilization gets to 70%, let's scale this up. So in a sense, with auto-scaling, we shouldn't exceed our throughput. Now, in the old school, requests exceeding the allocated throughput may be throttled. So something has to change. new way, we can scale up. The old way, we have to be throttled. We were sending more traffic that could be handled. But like I said, the auto scaling is really a game changer. And you can see that, again, we can set the minimum provision capacity and the maximum. This is obviously really maximum. So we can go ahead and change that. And again, it's just, even with auto scaling, it's good to have an understanding on these foundational concepts of provision throughput. So I'm going to go ahead and save. I change the maximum provision capacity, and there we go. So our throughput will scale based on this target utilization. So with that, we have completed talking about provision throughput and how it can be calculated, and the new feature of auto scaling, which I would not expect to be on the DevOps Pro certification exam just yet, but it's good to have an understanding for it because that could change at some point. So thank you for joining me in this lesson. Let's move on to the next.